An array is an data structure which can be defined as finite order set of homogeneous elements. Let us see what is an array. An array is going to start with the 0 to n minus 1 elements. You can able to declare an array by specifying the data type int array of size. Here we are going to declare the size of array. Here homogeneous specifies the type of the data. You can able to declare the data as a integer, float, double and etc. Now you have declared an array with the size of integer 4. Now let us see, here we have declared the storage of array 0 to n minus 1. Here the size of the array is 4. If it is starting with the 0 and it is going to end with n minus 1 of elements, 4 minus 1. So it means it is going to store 0 to 3 number of elements. Let us see how the particular array is going to store. Let us consider the array. Here it is going to start with 0, 1, 2 and 3. Now here I am going to start with the index 0, here 1, here 2, here 3. Now let us store all the elements inside the array 1, 2, 3 and 4. Now if I want to retrieve the elements inside the array, I am using a for loop. By using a for loop, I can able to retrieve all the elements inside the array from left to right. So let us type the for loop. For I equal to 0, it means 0 to n minus 1 element we will retrieve. For that I am going to type I equal to 0, then I less than equal to 3. So 3 is the maximum size of the array. So then I plus plus. Next what I am going to do is, we need to print all the elements inside the array. We have to assign the value to x. A of I equal to x, so that you have assigned the array to x. So I is an index of an array. So here if you are going to consider the 0, 0 is an index element. Here if you are going to consider 0, 0 is an index element of array. So what is A of I? A of 0. So which is 1. 1 will be printed at first. So next the for loop will be incremented. The I value will be incremented. So next I value will come to place of 1. A of 1. So now what is the value of A of 1? Array of 1 which is equal to 2. Next it will check the condition whether the value inside the array is less than equal to 3. So I value will be incremented. The next, first initially it is 0, next it is incremented to 1 and next it is incremented to 2. So now after it is going to check the 2. So what is array of 2? Array of 2 equal to 3. So now it will be incremented and it will check the condition. So whether 3 is equal to 3. So then the condition is true, then it goes to the 3. So now it goes to the 3, A of 3. So array of index equal to 3. What is the element residing inside the 3 is 4. So that it retrieves all the elements from left to right. So here it has retrieved index 2 and index 3. So this particular procedure, it has retrieved from left to right. how it has retrieved? This particular thing has retrieved from left to right. It has retrieved from left to right. So let us consider another for loop which is going to retrieve from back to front. Now for I equal to, so you are going to declare the size of array. I am going to declare I equal to 3. Then I am going to make a condition I should be greater than or equal to 0. I minus minus. Here we are going to retrieve the element from right to left. Because of that reason I am going to decrement the loop. Now we need to assign the value which is inside the array. A of I equal to x, so that we are going to retrieve the value whatever the thing is there inside the array equal to x. So let us say here the index value. What is the index value? 3. It goes to the 3 and check the condition. The first thing, the element inside the array will be printed which is 4. Next it goes in this particular direction. So it goes to this particular direction. Then it is going to print the value. What is the value? We are having array of 2. The array of 2 which we are having the index value is 3. 3 will be printed, and here if you are going to notice array of 1 which we are having a value 2 will be printed, and similarly it reaches the 0. So if it is greater than equal to 0, not greater than 0, if it is greater than 0, 2 will be printed. So it is equal to 0. In 0 we are having a value 1. So 1 will be printed. 4, 3, 2, 1 values are printed on the screen. Next we move to the concept called stack. A stack is a conceptual structure consisting of set of homogeneous elements and based on principle last in first out. Already we have seen array. Array is also set of homogeneous elements. Homogeneous defines it can be able to store similar data types. It means you can able to declare an array as an integer, array as a float, double, character, string, etc. The same type of elements you can store, but you cannot able to store mixed type of elements, integer, special character, string, all the data together you cannot able to store. So let us see what the stack. Basically the stack is going to work out with the principle called last in first out. Last in first out means if you are going to consider your school, in school your teacher will be correcting all the books, correct the book which is at the top element will be first. Here the operations you are going to have is if a stack. So assume this is a stack. Now here if you are going to assume this as a stack, here if a stack is empty, so here you are having a top. If a stack is empty, top equal to -1. Stack is empty, so then top equal to -1 if a stack is empty. Now what we are going to do is we need to insert some elements inside the stack. Now here we have declared a stack size of array 4. It means 0 to n-1. Here you can able to insert n elements from 0 to 3. Let us insert an elements inside a stack. Here I am going to insert an elements 1, 2, 3, 4, 4 number of elements. So it means here if you are going to see the stack 0, 1, 2, 3. The size of the stack is 4 and we have given 0 to n minus 1. It starts with 0, 1, 2, 3, 4 and so on. For example, you have inserted the value 1. So now here the top will be pointed from minus 1 to 1. Here the top of the element will be pointed to 1. So now if you are going to increase the element, if you want to insert the element 2, if you want to insert the element 2, the top will be incremented. Here top will be pointed here. For example, if you are going to insert an element 3, so then top will be pointed here. For example, if you want to insert an element 4, here the top will be pointed here. It means here it can able to store 0, 1, 2 and 3. So in this manner you can able to insert the elements. So now this particular insertion of element is called push. So now if you are going to consider the value, so you are inserting the 1 into the stack, this operation is called push. So you are going to push the value inside the stack. So now if you want to push 1, 2, 3 and 4. If you are going to make a operation called pop. So if you are going to make an operation called pop, what you are going to do is you are going to remove the element from top of the stack. It means you are going to remove the element. So pop is used to remove element. Push is used to insert an element into the stack. So here the insertion and removing the element. So now if you are going to see how you are going to insert and delete the elements in the stack. Here you are having an algorithm called push. So here you are having a push if top equal to size minus 1. So what is the size of the stack? So here we have given a size of the stack is 4. So 4 minus 1 is 3. So how many number of elements you can able to insert inside a stack? So here it is going to start from 0, 1, 2, 3. You can able to insert top size is 4, 4 minus 1. Now if total number of elements are 3, if top equal to size minus 1, so it means you are going to exceed the limit. It means the size is 4. So if top equal to here, the top of the element is residing here, stack top. The stack top is residing here. So now you are going to increase the size of the element. So if it is reaches the stack at the top of the element, you cannot able to insert more elements inside the stack. So here it is going to be overflow. If you are going to trying to insert an element inside the stack, if you are trying to insert an element inside the stack, so then it is going to set as a stack overflow. Otherwise else read the data item into the stack. So you can able to perform the push operation. You can able to push data inside the stack. So now top will be incremented. Again you can able to increment the top, and if there are by checking the condition, if the particular stack size is not full, then you can able to insert item to the stack. So where you can able to insert stack top item. So now where the top will be incremented, here you can able to increment the top. So if you are going to increment the top, like that you can able to insert. So next one is pop operation. In pop operation, what we are going to do is, here we are going to make the if top equal to -1. So basically here under that one, top equal to -1. So initially here you will be having a top, so top equal to -1. So then it cannot able to, you cannot able to decrement the stack, you cannot able to pop the elements. So here assume here you are having a 0 1 2 3. Here you are going to perform the pop operation. So you have popped the element, assume the elements are 1. Here you are having an elements 1 2 3 4 elements. You have popped the element 4. 4 is popped right now. Now top will be decremented. So now it is removed. This particular element is removed. Now you need to decrement the top. So you are going to decrementing the top -1. Top equal to top -1. So whatever the element index will be decremented. So now 3 will be decremented to 2. So now the 2 value is 3. So 3 value will be popped out. Next here again it will be decremented to 1. So now the value 2 will be popped out. Here we are going to perform the pop operation. So we have popped and it has reached to 0. So here we are going to check the whether the item is pointed to stack top. So then here you are having a top, so then you are going to pop the item. So now here we are going to check top equal to -1. We have reached the top equal to -1. So after 0 the stack will be null. There is no more elements inside the stack to pop. So if top equal to -1, then we cannot able to pop any item, then it is going to print the value stack underflow. So now we need to check other conditions, whether the stack is empty or stack is full, so that if top equal to -1, so if top equal to -1, it has to return 1. It means it has not executed successfully. 1 defines not executed successfully, else return 0. Return 0 specifies it has executed successfully. So next, if stack is full, so if top is less than the stack size, it means stack size top is less than the stack size, you can able to insert. So otherwise else return 1. This is all about stack. Next class we will discuss about stack operations, infix, prefix, postfix. Thank you.